Okay, so we are going to talk about absolute value equations. And absolute value are these symbols that are kind of straight lines, and they represent the distance of a number from zero. So the absolute value of a real number is just the distance from zero on a number line. So, as you might guess, distance can only be positive. So distance is always positive. There is no such thing as a negative distance. So when we think about the absolute value of a number, it has to be positive. So if this says the absolute value of x equals 2, there are two options for numbers which could be true. Think about a number line. Here is 0, here's 1, and here's 2. What is the distance of 2 from 0 on the number line? Well, the distance is 2. But there's another number that is also 2 spaces away from 0, and it is -2. But we would still say that the distance, or the absolute value of that, is 2 spaces. So both -2 and +2 are 2 absolute values away from 0. And so this number x could be a -2, but it could also be a +2. If I say the absolute value of 2 equals 2, that is true. If I say the absolute value, or the distance, of -2 is 2, that's also true. So there are two possible answers. For this option over here, we see the absolute value of x is equal to -3. And like I just said, absolute value cannot be negative. So this equation cannot be true. There is no number or no solution that will work in this problem. There is no number that the absolute value is equal to a negative number, because absolute value has to be positive. Distance is always positive. For number 3, we see an example where the absolute value is equal to 0. Well, the only number that is 0 spaces away from 0 is the number 0. So there is only one solution to this problem. There is one solution, and the solution is 0 in this case. Here, there were two solutions. We had two numbers that would result in an absolute value of 2. So when we see these answers, we're going to have three different things happening. One is there may be two solutions. One, there may be no solution. And one, there may be just one solution. So let's look at an example. Here's an example of a two-solution problem. What we're saying is the absolute value of this information is equal to 13. So if I set this up, I know that this information here has to be equal to +13, or it could also be a -13. It could be 13, or it could be -13. So I'm going to set up two equations that say that. The first equation is going to say 2x plus 5 equals 13. The second equation is going to say 2x plus 5 equals -13. And this is going to help me find the two answers, which could be x. So when I look at this equation, I need to do the same solving for both equations, right? Just like we have with two-step equations. We're going to subtract 5. That's going to have us cancel our 5's. And then we're going to end up with 2x equals 13 minus 5 gives me 8. And then I'm going to divide by 2. So I get x equals 4. That is one of my solutions. But as I know, if the absolute value is equal to a positive number, I should have two solutions. So I'm going to do the same solving on the other side. And I'm going to get that 2x is equal to -13 minus 5 is going to be not -8, but -18. Because two negatives make a bigger negative. And then I'm going to divide by 2, so I get x equals -9. So I have two possible answers, which in this equation could work to equal the distance from 0 is 13. As we start to look at these, you're going to see that these other ones are not going to have two solutions. So looking at number 2, if the absolute value is equal to 0, there is no such thing as a positive 0 and a negative 0. There is only 0. So I really only have to write one equation saying that 4x minus 5 is equal to 0. And then I can solve. Plus 5, plus 5. This gives me 4x, these cancel, is equal to 5. And 4x, I need to divide my 4. And so I get x is equal to 5/4, or that equals 1.25 if you want to write it as a decimal. Also a correct answer. But there is no other answer. There's only one solution, right? Here we have 1. Here we have 2. Over here, we're going to see what happens when we have an absolute value equals a negative number. I cannot have an absolute value equaling a negative number. This is not a true statement. So actually, these are the easiest problems because I do not need to solve. All I need to do is say that there is no solution to this problem. And I'm done. All right, let's look at some other examples. So going down to the other ones. In these ones, you will notice that the absolute value is over on the left, but then there is something subtracted from it. So before I can set up my equation saying that my absolute value is equal to something, I need to move this 3. This 3 is outside of my absolute value symbols, or outside of the kind of parentheses that I see. So I want to move this plus 3, or this 3 using a plus 3. And when I do that, I'm going to end up with not the absolute value equals 11, but the absolute value of 3x minus 4 equals 11 plus 3, which is 14. And now I can say, okay, this is still positive. This absolute value equals a positive number, so I should have two equations. One that says 3x minus 4 equals 14, and another equation that says 3x minus 4 could equal negative 14. One positive and one negative option. When I do that, I'll solve each of them the same way. The steps will be the same. I will add 4 and add 4. I'll get 3x equals 18 on this side, and divide by 3, and x equals 6. And on this side, I'm going to do the exact same steps, but I will get a different number here, because negative 14 plus 4 is negative 10. So I get 3x is equal to negative 10, and then I divide by 3, and I divide by 3, and I get x is equal to negative 10 thirds, or negative 3.33. That's the decimal version of that. If you put this in your calculator, that's what you'll get. Over here, you're going to see what happens that will end in a 0. So again, I need to have my absolute value alone on one side of the equation. So I'm going to move this positive 4. When I move the positive 4, I use the opposite, a negative 4. That's going to cancel. On this side, I'll have 2x plus 1. The absolute value of 2x plus 1 is equal to 4 minus 4, which is 0. When it equals 0, again, there's no positive 0 and negative 0, there's just 0. So I only need to solve one equation, 2x plus 1 equals 0, and then I can subtract my 1, and I end up with 2x equals negative 1, because 0 minus 1 is negative 1. And if I divide by 2, I should get x equals negative 1/2, or 0.5, negative 0.5. Either of those answers is okay, the fraction or the decimal. On this one, you're going to see what happens when we have a negative number. So again, I need to get my 7 away and my 4 away, just like I would with a regular problem. I'm going to move that using a minus 7. 4 minus 7 is going to give me negative 4. This one's a little different because it also has a 4 outside of the parentheses. Remember, if it's a 4 outside the parentheses, that is like multiplying by the absolute value brackets or parentheses. So I can divide it away. If I divide it away, I'm going to end up with x minus 1. The absolute value of x minus 1 is equal to negative 1. We know that a negative number cannot be an absolute value, so this problem does not have an equals. It has a not equals. This cannot be true. So we know there is no solution. Just like in the example above it, we had to do a little solving first, but we got to the point where this absolute value equaled a negative 1, which can't be true. So we write no solution. For the last examples, you're going to see a couple more practice problems like this. So how do I solve? First, for the absolute value symbols, I'm going to move the 5, and I'll end up with 2 times the absolute value of 2x minus 5 equals 11 minus 5 gives me 6. I have a 2 multiplied by the absolute value, so I'm going to divide it, and that gets rid of it. So I have the absolute value of 2x minus 5 is equal to 6 divided by 2 is 3. At this point, I look at the absolute value. It is all by itself, and it is equal to 3. That's a positive number. If it's a positive number, there's 2 options. It could be equal to positive 3, or it could be equal to, x minus 5 is equal to negative 3. And I can solve those 2 little equations to find my 2 answers. All right, so I do plus 5, this is 8, equals 2x, and then I divide by 2. X equals 4. On the right side, I'm going to add 5, and I get 2x is equal to negative 3 plus 5 is 2, and I divide by 2, and I get x equals 1. I have 2 answers because I have a positive number that the absolute value is equal to. On this one, I'm going to do the same. I'm going to subtract the 9, and then I'll divide by the 2. So subtract the 9. That gives me 0. 9 minus 9. I have 2 multiplied by 2x minus 5 is equal to 0. Divide by 2. 0 divided by 2 is still 0. 2 over 2 cancels, and we get the absolute value of 2x minus 5 is equal to 0. If the absolute value is equal to 0, that is the only equation we need to solve. We just need to solve 2x minus 5 is equal to 0, because there is no positive and negative 0. There's just 0. So the plus becomes a minus, and we have 2x equals 5, and we divide by 2. So we get x equals 2.5. I can see that. There you go. Last one. This one's a little trickier because the 5 is in the front, but remember, when there's a 5 in the front, this is a positive 5. So we are going to subtract 5, and we still have our negative 2x minus 3 is equal to 7 minus 5 gives me 2. This negative here, remember, if you have a negative and no number, that means there's a negative 1. So I'm going to divide by negative 1 and divide by negative 1. Now I can see that this and this cancel. I still have the absolute value of 2x minus 3 is equal to 2 divided by negative 1 is negative 2. Now, if the absolute value equals a negative number, this is not possible. If it's not possible, that means that this cannot be true, and so I can stop and I can just write no solution. So I've given you 9 examples of how to do this. 3 of each type. 3 that are 2 solution problems. 1, 2, 3. 3 that are 1 solution problem because they equaled 0. and 3 that are no solution problem because the absolute value was equal to a negative number.